Okay, for what we have in this particular sample problem, okay, we have the concentration C of T of a drug in the bloodstream T hours after ingestion is where we have C of T is equal to 10T all over 2T squared plus 1. And we have for the first question, which type of function best describes C of T? And it says to choose from polynomial, rational, exponential, and logarithmic. Okay, now for polynomials, okay, again, we don't have this type of function, okay, and in terms of exponential, you don't have a standalone base by itself raised to a power, and the t squared alone, since this is packaged in the fractional form, okay, this is not going to enable what we have in C to be an exponential function, and we don't have any logarithmic terms in the mix. And if I were to try to write this as separate terms, what we have in the combined expression, again, we're not going to have a polynomial. And since the function is given in fractional form, okay, this is going to end up as a rational function. Okay, so for the result in number 1, okay, this is going to be a rational. Now we have, in the case of the second problem, it says to find what the domain of the function is going to be. And we have neglecting the context of the problem. Okay, and we'll get into the context in just a moment. And it says to give your answer in interval notation and support your answer algebraically. Okay, so we have for this rational function, okay, once again we have item 1 is a rational function. Now for the domain, okay, again, we have a rational function, and in order to be defined, the denominator cannot be equal to 0. Here we have the denominator to be 2t squared plus 1, and again, this cannot be equal to 0. And looking at trying to solve for t, and that is finding out what the exclusions are going to be. So if I isolate the t term, okay, so right now I have 2t squared. If I isolate, taking 1 away from both sides, I'm going to have that 2t squared cannot be at negative 1. And then we have getting t squared by itself. I have with division by 2, t squared cannot be equal to negative 1/2. And with the square root property of equality, okay, so again, if I take the reduction from t squared to t, I'm going to have plus or minus the square root of the constant on the right. So we have that t cannot be equal to plus or minus the square root of negative 1/2, and we had that t cannot be plus or minus the square root of 1/2 of I. Well, guess what? These are a couple of complex additive inverse values, okay, and they are not in the real number system. So we have no real exclusions or from the domain, okay, and so that means that since we have excluded or tried to exclude from the domain a couple of complex numbers, well, guess what? Complex numbers are not part of the real number system, so there are no real exclusions. So we're going to have for the domain, this is going to be the set of all real numbers. And for what we have in interval notation, okay, for item number 2, okay, the domain, we have the set of all real numbers, and in interval notation, we have parentheses around negative and positive infinity. Okay, for question number 3, it says to give the domain of the function in interval notation, taking into consideration the context of the problem. Explain your reasoning. Okay, so again, not taking into context for the domain, okay, just in functional terms without the context. Again, I had the set of all real numbers. Now putting it into context, taking what we have in context. Now domain is in reference to the time t, which is in hours. And in the case of ingestion, okay, there's no such thing as negative time, so the very minimum value is going to be 0 in context. So the domain we have inclusive of 0.0 or 0 seconds. We're going to have a bracket around the 0, and again you have going continuously out to infinity. Now for the fourth question, it says to find the horizontal asymptote of C of t and explain its meaning in the context of the problem. So for what we have in the case of number 4, okay, we had that C of t is equal to 10t all over 2t squared plus 1. And if we look at horizontal asymptotes, remember you're looking at involving degree comparisons between the numerator and denominator. So we have at the top, we have n is equal to 1. And this comes from t to the first. In the denominator, okay, we have m is equal to 2. This emanating from the square of t and 2t squared plus 1. Here we have n is less than m, and if the degree of the numerator is less than that of the denominator, we're going to have a horizontal asymptote, y is equal to 0. And what does this signify? Well, the 0 means that the possible minimum concentration will be 0. That's going to be the absolute minimum. Okay, so that is going to be 0. Okay, so we have for parts 5 through 8, it says you may use a graphing utility and refer to the graph of C of t. And we have in number 5, it says to determine the maximum concentration of the drug in the patient's bloodstream, including appropriate units. And number 6, we have when the maximum concentration is going to be reached. Okay, so we're going to have in Desmos. And just setting up the framework, so we have our function. So we're going to have y to represent c and x to represent t. So you're looking at the xy coordinate system of the equivalent of c is equal to 10t all over 2t squared plus 1. Okay, so in terms of the maximum point, so if you notice in the graph, the maximum point, we have to be this location, which we have at 0.707 and 3.536. And the 3.536, that is your y value, which will be in reference to the concentration. So 3.536 is going to be the maximum concentration, and that 0.707 is going to be the amount of time. So we have, again, for the maximum concentration, you have right at 3.54, and the time upon which the maximum is going to be reached is right at 0.707. Now, in number 7, we're looking at the intervals of increase as well as the intervals of decrease. And if you notice, okay, where we have going from end to end, so we're looking at going down, and then you have this blip, so you have going up, then you have followed by another decrease. And for the increase, this will be for the values of t, or in the graph you have x greater than negative 0.707 and less than 0.707. That is for the increase. Now, where we have decrease, you have going from negative infinity on out to approaching the value that is less than negative 0.707. Then we have at the other end of the spectrum, we have another decrease, and this will be for those values of t that will be greater than 0.707. So for the interval of increase, you have, again, between negative 0.707 and positive 0.707. And for the intervals of decrease, you're looking at, again, those values of t less than negative 0.707, as well as those values of t greater than 0.707. Now, looking at what we have in the activity placing in context. And we have for number 8, considering the exercise in context, on what interval or intervals is the concentration of the drug increasing? Okay, so again, we have no negative time, and so we're going to have, in this particular case, all right, we're going to have, again, just starting out at time, t is equal to 0. So you have in context, okay, no negative time, so you have the increase, okay, so you have, okay, going past time 0, okay, you have approaching 0.707. And we have, after that, you had the decrease to be for the time after 0.707.